Hello all, welcome to the session on Exploratory Data Analysis Basics. Today, I'll be teaching on the basics of EDA. I am Mangir Karasi, your instructor today. I am an AML evangelist, mentor, manager at Tier 2 Every, and I also head AML Center of Excellence. I have 20 plus years of experience in IT industry, which includes 5 plus years on AML. Currently, I am working as part of digital innovation team. I am responsible for building different AI and ML solutions for various business units and customers. I also mentor my team, business units based on the project needs and freshers who are keen to work on AI/ML projects. I engage with business units and customers to bring in ideas and innovation into real-time solutions. I have completed my PG diploma in data science from IIIT Bangalore. Today's session covers the overview on exploratory data analysis, data exploration, data transformation, and feature engineering. The next session will cover visualization techniques and hands-on coding to implement EDA in a project. Let's start with the overview. Exploratory data analysis is a key process of performing initial investigations on data to discover patterns, spot anomalies, test hypotheses, and to check assumptions with the help of summary statistics and graphical representations. EDA is a crucial step as it ensures the results produced are valid and applicable to business outcome and goals. The visualization or the dashboard, which is derived out of EDA, helps the stakeholders to check whether the results achieved are right. EDA focuses on all contexts of data and the outcome is statistically calculated, modeled, and visualized. If EDA is not done properly, then it can lead to wrong prediction, which affects business solution. So EDA helps in gathering insights. For example, we need to know what are the important features of the data that we need to concentrate in getting higher accuracy. The highlights relationship between data points. It is necessary for us to understand on what basis we take decisions to retain the data. It assists in restructuring the data for data modeling. It may be needed for us to restructure the data based on the business to derive better insights. For example, if we are given a datetime field, we may have to come up with the restructure like extracting the datetime and then checking whether the sales is happening in the daytime or in the nighttime. It helps in removing redundancies from the data. The same data features, if repeated and used for data modeling, will affect the performance metrics of the data model. So we need to carefully investigate and perform EDA so that it results in better accuracy. So the time spent on EDA is very critical, as if there is not enough time spent, then the results may not be desirable. It actually makes the data modeling easier as we address data quality issues, know what are the important features, and remove the trivial data as part of EDA. When we talk about a data scientist profile, everyone thinks, okay, once I'm a data scientist, I will start working on the data. I have to build various data models, I have to check what is accuracy, I have to look, okay, what is the performance metrics that is needed for the business problem. I may have to deploy it. There are lots of activities that is done as part of a data scientist job, but you'll be really surprised to see how much time a real data scientist spends on data modeling or building a data model or deploying. When you see the graph that is given here, you see most of the time that is spent by the data scientist goes on collecting the data and cleaning and organizing the data. The collecting of the data contributes around 20 percentage, as they may have to analyze what is the data source. It may be necessary for the data scientist to understand the domain and where the data lies. Is it available? The timelines of the data availability, is it available just for 3 months because they could have started a new system, or if it is a legacy system they may have missed out some years of data, they would have not recorded the data, so that results in data lack of data. The data quality issues, it may not be necessary, like in the primitive stages they might not have stored certain data, or they would have an invalid data stored because the data validation was not done as part of their project. And selecting the right data. If my business, so we have the data available, but we need to select the right data for the business solution that we are targeting. There could be thousands of features that is given to us, but if we select wrong features, then this may lead to undesirable outputs. So as mentioned earlier, exploratory data analysis and visualization is a very important step in any analysis task. So we need to know the data, how the data is distributed, whether it is a normal or skewed. How is the okay? If it is skewed, then it means that we the data may be biased and it may lead to undesirable outputs. Say if I'm given a data to know if I have to say whether the given data is a dog or a cat, and I have more data on dogs and the cats are less, then my model would be trained with more of the features of dogs. So if any pictures that come to the project will be categorized more on dog rather than a cat. So we should understand how the distribution is there. If there are any data quality problems, then how do we address these data quality problems? And outliers. Yeah, outlier is the data item which uh, deviates significantly from the rest of the data. So if I'm given the employee salary data and I have more, since the higher profile jobs have very high salaries, then it may be it may sometimes it may lead to a bias in the data, or it may result in skewness. So we may have to remove these outliers, and it is not necessary for all the outliers. We may have to remove it um, once we get to see the outliers. It may not be necessary that we have to remove all the outliers. So it depends on the business problem that sometimes the outliers needs to be retained. It is all the business decisions that derives that runs the data modeling. The correlation describes the strength and association between the two variables. So how the two variables are associated. Say, for example, the make of the car will be closely related with the price. For example, if it is a BMW or a Porsche made cars, then the price of the car is normally very high. Whereas if it is going to be a Ford or Chevrolet or Hyundai or Toyota, then we have a certain range for these price of the car. And it is suggested that we know what is the functional relationship between the data features that we are going to work, which helps in better data modeling. So it is not necessary that an AML project follows an end-to-end implementation. So as mentioned earlier, when you talk about any AML project, it is not necessary that it should start from an EDA. We will be training data sets, test the data set, perform data modeling, and see based on the various performance metrics which data model works best, and then deploy it and monitor it. The customer might be solely interested to understand how the data is distributed or what is relationship between the data, and based on these details, what are the insights that he can derive for his business. In those cases, EDA only will be the goal of the project. Data exploration is the first step of data analysis, which is used to explore and visualize data to uncover insights. It helps the user to have broader understanding of the business and make better decisions. So we should know how our data is, what are the variables that is available in our data set. And for any AML project, we always talk about statistics, and various concepts of statistics are being involved for ML projects. So we should understand what is the summary or the descriptive statistics that is available for these features, and then we'll be making use of these statistics as and when needed. The visual analysis, it shows you how the data is displayed in the form of graphs or charts. This will help mostly the management or the stakeholder to understand how the business runs, what are the various insights that they can get out of the EDA. So know the data types of the data set. We have discrete, categorical, and continuous. The discrete values are distinct and separate. That means you'll be able to count it. Like what is the number of people in a class, what is the population of India. So you are able to count the values. Categorical it is more of a characteristic data where we talk about the gender. For example, gender, you can say male and female. And the students, for example, when we consider school, you can list out teachers, students, principal or workers who are available in a school. So moving on, we have continuous. Continuous data represents the measurements, and these values cannot be counted. It can only be measured. For example, what is the weight of a water bottle, or what is the height of a student, what is the temperature of the plant where it is yielding. The summary or descriptive statistics, it again takes it specifically for categorical and numerical values. Categorical values is mostly the number of counts. For numerical values, we can go with what is the mean of the numerical value, median, mode, what is the minimum height or what is the maximum height, what is the range of the weight of the students of class of grade 5, what is the variance, standard deviation, how it is skewed, is it right skewed or left skewed. So all these summary statistics will be taken into consideration. The next step is the visual analysis. So here we talk about univariate, bivariate, and multivariate analysis. The univariate analysis is we take up one single feature and then we start analyzing what is the mean of this specific feature, what is the maximum value, what is the minimum value, how frequently is it distributed. Bivariate analysis, it is a relationship between two variables. So here we talk about what is the relationship. Is it positively related? Based on one variable, how it affects the relationship of the other variable. Multivariate analysis, if more than two variables are involved, then it is called the multivariate analysis. As mentioned earlier, univariate analysis provides a summary statistics of each field. So here I have given few examples like gender ratio and the car, how it is related with the price. sorry, what is the count of the cars, each of the cars, how it is, what is the make of the car and how much sales it is happening. So we use few graphical representations for that. We can use box plot, histogram, bar chart, pie chart, and other charts for visualizing univariate analysis. Bivariate analysis is performed to find the relationship between two variables. Basically, it will be the target variable and the independent variables available in the data set. Here, as I have mentioned, I have given an example of how the car make is given. So you can see the BMW is highly priced. Volvo is onto the medium, and I think it is Bugatti where this is highly priced. So based on the make of the car, the price increases or decreases. We are using scatter plot, line chart, box plot as part of visualizing these bivariate analysis charts. The next topic is a multivariate analysis. This includes understanding the interactions between different fields in the data set. So I again have taken the sample of the car. The visualization methods that we are using are box plot, heat map, scatter plot matrix, and tree map. And the example that I've given here is the heat map. So if you're able to see, this is the price of the car, and it tells you whether there is a numerical value that is associated, and you can see a negative sign here. If there is no negative sign, then it means that it is a positive. So this represents how strong the relationship is, and this positive or negative determines how is the strength associated with it. Data transformation is a process of converting the data or information into another format. So the various data transformation techniques used are data cleansing, data binning or bucketing, indicator variables, centering and scaling, data transpose rows into columns, or vice versa. Data transformation is a process of preparing the data for analysis. We just remove the data or we modify the data so that we ensure that there is data correctness and there is data completeness. So we have a lot of things when we talk about data quality, like there could be invalid values, there could be different formats for a specific feature, uniqueness, missing values, there could be duplicate values, there could be misspellings. So these are the data quality. These are some data quality issues that we may face. So if you're not going to work on this, then this may lead to wrong decisions or conclusions made by the business. So this is a crucial step that is performed as part of EDA. How do we fix these issues that is mentioned as part of the earlier slide? So if there is a misspelled data, then we correct it with the right one. If there is, if the specific feature is unique, then if there is a duplicate scene, then we ensure that we switch that duplicate field with another value that is not as part of the feature, ensuring that there is uniqueness. Missing data, the most common thing that we see as part of the data quality issues is a missing data. So here we approach the numerical column by imputing it with a mean, median or mode, and if it is a categorical column, it is mostly we imputed with the mode for that specific feature. Formats, as mentioned earlier, there could be different formats that we are using. I could have pulled it from various data sources. One data source could use a decimal format which has 4 values, or from other data source it could be rounded off to 2 values. So I should be able to, when I use my data for the AML project, I should ensure that it is of the same format. Either I'll go with a 2 decimal point, or it can be rounded off to 4 decimal points. Similarly, for the dates, It could be MMDDYYYY, or it could be DDMMYYYY, or it could be other date formats. So as per the decision business, we'll ensure that we come up with a standard date format value, and we change the data format to this generalized date format. We have been talking about indicator variables, data binning or bucketing, centering and scaling, data transpose. So indicator variables is converting the categorical data into Boolean values. As mentioned earlier, you have seen there was a categorical variable called gender. So here we saw male and female. When we use the data output from the exploratory data analysis into data modeling, all the values should be converted into numerical values. So if there are any categorical variables, then we convert these categorical variables into Boolean values, or it could be numerical values. Data binning or bucketing, it is dividing the data into specific intervals. For example, if I'm going to work with the Amazon sales data, then I can say my monthly purchase could be from 0 to 5,000, could be one bucket. 5,000 to 10,000 could be another bucket. 10,000 to 20,000 could be another bucket. So we are defining these buckets based on our business decisions. Centering and scaling. Uh, when we talk about normalizing of the data, the centering and scaling is one of the pre-processing technique that is used for normalizing continuous variables to be in the same range. This is done to ensure that we have a better predictive model, which may require data to be scaled up or down appropriately. Data transport rows to columns. Sometimes it may be necessary for us to transpose the rows into columns or vice versa. So this is done as part of data transformation technique. The final topic that we'll be looking at is the feature engineering. This is the art and science of selecting or generating the columns in a data table for a machine learning model. The goal is to improve the accuracy of the predictor. The subcategories of feature engineering are feature selection, dimensionality reduction, feature generation, or feature extraction. Feature engineering, using the correlation plot, we were able to find what is the strength and direction of the correlation. As you have seen, the strength responds to the numerical value, and the direction of the correlation is given by whether it is positive or negative value. So a positive correlation is if the variable increases, then the other related variable also increases. If the variable decreases, then the other variable also decreases. Say for example, based on the make of the car or the number of seatings that is available in the car price increases. Say if it is a four-seater, in general terms, if it is a four-seater, then it will have a specific range. But if it is a seven-seater or eight-seater, then the price of the car normally increases. The negative correlation is it happens in the opposite direction. Say if the price of the car increases, then it is related to the variable where there is a decrease. So for example, if the fuel type is diesel, then the price of the car decreases. Or if there is a hatchback car, if that feature is available, then the price of the car decreases. No correlation is exist between the variables where there is no relationship. Say if there is a change in X, but there is no impact on Y. Say for example, there is a horsepower of the car, which when the horsepower increases, then the price does not increase. So it does not affect the relationship between these two variables. So the next technique is the dimensionality reduction. It refers to the process of converting a set of data having vast dimensions. That is, if there are too many features that is given to me, then I will work on the data to ensure that I have lesser dimensions, but I have all the critical features that is needed for my data modeling available in those dimensions. Say for example, I'm given the data, I have both age and date of birth. So I'll be able to remove either date of birth or age based on my business problem. It is not necessary for me to have both of these features as they give me the same information. So there could be a lot of other features which is available as part of my data which provides the same information, and this will lead to multi-collinearity. So it is necessary to apply dimensionality reduction in those cases, and we have lesser variables or features which provides better accuracy for the problem that we are resolving. So there are, I have given certain examples of the dimensionality reduction. We have principal component analysis, which is applicable for an unsupervised model. It focuses on capturing the direction of maximum variation in the data set. We have LDA, which is linear discriminant analysis. This concentrates on supervised algorithms, and the goal of LDA is to find a feature that surpasses the best optimizes the class separability. And GDA deals with nonlinear discriminant analysis using functional kernel operation. This technique is applicable again on supervised algorithms, and it works very similar to LDA. There are other popular dimensionality techniques available, which are kernel PCA and truncated singular value decomposition, which is called as SVD. So dimensionality reduction avoids the problem of overfitting, and it also addresses multi-collinearity issue. We are lowering the number of dimensions, means we are having lesser training time, and this leads to lesser computational resource, which helps in increasing overall performance of ML algorithms. Feature generation. This is a process of constructing new attributes from the raw data. So we are able to obtain new features either by combining other features or by splitting one feature into multiple features. This involves intelligently combining or splitting existing raw attributes into one which have higher predictive power based on domain knowledge. So if a sales data is given to me, as mentioned earlier, if the date and time stamp is available, I may divide it into day, month and year. So which will tell me at which year my sales was the highest, or which month my sales was highest. Say for example, if there is a festival season, then my sales may go up. So if I'm forecasting what would be my sales, then I can convert this timestamp variable into day, month and year, and see where my actual sales is higher. Similarly, when I have a daytime stamp, or I have the last purchase time of the Amazon sales, then I may have to come up, it is based on the business decision problem. I can come up with what is the average time between the past purchases, or what is the average amount of past purchases, what's the time elapsed between my last purchase, or what's the total number of past purchases. So these are the new features that I'll be able to receive based on the features. So thank you all, and we'll meet again in the next session, which includes visualization and hands-on coding.